Hey guys, it's Aaron with Heritage Home Service. Today we're going to be going over an oil boiler maintenance and some of the major points we inspect during the process. So let's go check out the equipment. After entering the home and setting our agenda of what we're going to do today with the customer, one of the first things we want to do is test the thermostat for proper function. And we simply do that by turning up the thermostat above the ambient temperature in the room to make sure the system comes on, which it just did. Now we want to turn it back down again below the ambient temperature in the room to make sure it shuts off. One of the last things we're going to do is once again set the temperature above the ambient temperature in the room so that the system's running when we go down to check it out. All right, so we're about to begin our maintenance today, and one of the most important things before working on any equipment at all is to shut the power off in two places. One, we want to shut it off here at the boiler, and then, if able, we want to go over to the electrical panel and we want to shut the breaker off, that the burner, this boiler and burner, that circuit it's on. That's very important for our safety and that of our customers as well. All right, before we begin our maintenance today, one of the first things we want to do is inspect our oil tank. This particular oil tank is called a Roth tank. It's actually a double-walled tank. So we have a plastic liner on the inside and we have a galvanized steel shell on the outside. These were designed to be actually an outside tank. There's another portion of it, which is like a doghouse that goes on top. But one of the things we want to do if we have a steel tank or a Roth tank is to take a look down to see if there's any leaks. In this case, what we do is just look all around the base. Do we see anything that looks like there could be a leak, or the sides wet, anything like that? In this case, there's nothing. If this was a steel tank, we'd be on our hands and knees looking at the belly of the tank. We'd be looking at where the pipe comes out that supplies the oil filter or the oil line. We want to make sure that there's no weeping around that. We want to look at, if it's a steel tank, there's 4 legs it sits on. What's the condition of those legs? Are they rusting? Are they rotting? And again, on the belly of the tank, is it rusting? One of the things we look at too up here and on Roth tanks, these are where our pipes come in. And we have a fill and we have a vent. And what we want to check for here is right around the base of these. Sometimes if these nuts are not tight, we'll get oil that'll weep. What happens is when the oil guy comes, he's pumping his fuel sometimes 60 to 80 gallons a minute and the tank gets pressurized. So all that oil that's sloshing around in there will find a way out if these are not tight. So in this case, they're nice and tight. And on a steel tank, it's the same situation. You'll sometimes on some of the older tanks, you'll come in and you'll see staining around these because the thread compound will deteriorate over time and the oil will start to weep out. So again, that's not a safe thing. So we want to make sure that we're not seeing any staining down the sides of our tank or any signs of wetness. So now that we've performed the inspection here, this tank is new and it looks good, we're going to move on to do our oil maintenance today. So here we are in the basement in front of the boiler we're going to be working on today. This is a standard forced hot water boiler. These are some of the hand tools and some of the equipment we're going to be using today to perform this maintenance. At Heritage, we do a 33-point maintenance checklist. Our average maintenances take about 2 hours. Today, we're going to be going over some of those points and discussing some others. All right, so we're ready to begin our maintenance. First thing we're going to do today is change the oil filter. This particular oil filter is located on the side of the boiler and is part of a deaeration unit. We have an overhead oil line, and because of that, we don't want any air pockets developing inside the oil line, which could cause the system to go down or essentially shut off. So what we have is a deaerator, and the filter's part of this. A lot of times the oil filters themselves are located at the oil tank, at the base of it, but in this case it's here. So what we're going to do today is we're going to actually spin this filter off, change it, and change the O-ring that's part of it. The key thing is to have a large containment bucket for your oil that's going to drip out of this, and then a oil absorbent towel below it. The reason for this is we don't want to have any oil splash on the customer's floor. So these are the tools we're going to use today to change this filter. We have a standard filter wrench attached to a ratchet, and we have an awl right here, which is going to help us remove that O-ring, which can be troublesome sometimes. Right now we're spinning the filter off as it's threaded, trying not to spill any of the oil inside. And we're going to set it down in our oil bucket. It will be full of oil. Next thing we're going to do is try to get this O-ring off which is right here. We're going to put the new one on. There's a little groove it fits into and snaps up in there. And we're going to take our new filter. There's a gasket on here. We're going to want to wet this with a little bit of oil. And then we're going to thread it on. We only want to make these snug hand tight. You never want to tighten them more than that, as they'll be impossible to get off next year. Now that we've done the oil filter, we're going to be moving on to the pump strainer. We only need one tool to do that. Sometimes it's either a 5/16 driver, nut driver, or this hex head tool, depending on the type of pump. And this is our fuel pump strainer, which is actually catches any of the debris that's missed by the filter. So what we're going to do is we're going to take our tool, and again, we want to make sure our fuel containment bucket is underneath this pretty good because it is full of fuel. And there will be some extra residual fuel draining out of the deaerator. This is the gasket. We're going to replace that. And this is the old pump strainer. We're going to replace that. You can see there's a little bit of debris right there. So it's doing its job. We then want to take a clean rag and wipe this guy out really good. Get any of the loose sludge or debris that's in there out. We also want to take our rag and clean the surface of this pump, make sure that there's no sludge on it. But we want to be very sure that we don't leave any lint behind from whatever rag you may be using. We're going to take our gasket, put it on. We're going to take our pump strainer. This is our new one. And then we'll take our housing and our bolts. We want to make sure these are nice and snug but not over tight. We want to just make sure that we have that gasket in there nice and pressed. Just go around and make sure they're all snug. And then make sure everything is wiped down. All right, so now we're going to open up the burner and change the fuel nozzle. This is probably one of the most involved portions of the maintenance we're going to perform today. So essentially on this burner, the fuel comes out of this pump. This is the pump. We just changed the strainer in it. It goes in through this line, and it goes into what we call a drawer assembly that goes into the boiler. And at the end of that drawer assembly is an ignition source, two igniters. They look like two prongs, which I'll show you. And we have our nozzle. So let's go ahead and try to get that nozzle out. First thing we're going to do is take a 7/16 wrench to take this fuel line and detach it, the jet line, detach it from the burner. And then there's a nut right here that holds the drawer assembly in. We can remove this as well. Next, we're going to open up. This is our igniter right here. This is what provides the electricity that essentially creates the spark to ignite the fuel. So this unit and the igniters are like a spark plug in your car, essentially. So these are where the electricity comes from. And this particular device right here is something that's very important and we want to inspect. That device is called a CAD-CEL-I, a cadmium sulfide resistor. It's the same thing that senses sunlight on your lights that turn on and off with the sunrise or set. Well, essentially what this does is make sure that there's an actual flame going on inside. If it doesn't see a flame, that means there's a problem. Either the system's sooting up or there's another issue. And what it does is it tells this guy to shut the system down. So it is a very important safety feature, and they actually remove. And what we want to do is inspect that little lens in there for any clouds, cracks, or any deformities inside there, because if there's anything like that, it needs to be replaced. In this case, this one's brand new. Next, this is the drawer assembly. And these are the ends of our two electrodes that make that spark to ignite the fuel. And we want to pull this guy out. Careful because this is full of fuel, so I usually grip it Now, there's our fuel nozzle. These are our electrodes. And a spark goes across those two and ignites the fuel. This is what we call a retention head. And the air blows down this tube from the fan inside here, which you can see, which we inspect as well as part of the maintenance to make sure that it's free of any debris and it spins freely. It forces the air down through and then goes through these little fins. And the fins cause the air to turbulate, to spin. And when that happens, the fuel is sprayed through and it mixes with that air and it's ignited by these electrodes that stick through right there. So we want to make sure this head is clean and clear, those slits, of any debris. So that's part of our maintenance today we'll be performing. So next, I'm going to drain the head. And we're going to remove this by taking our screwdriver and we're going to pull this head free. We can set this guy down and we'll put our attention on the head right now. So you can see there's a little bit of black soot that's developing right there. So we have a wire brush that we're going to perform, and you want to make sure that you do it over your oil bucket or a place that it can contain it, and we want to clean this. And then we want to inspect it for any damage, cracks. The cracks can occur because the heat can actually fatigue and stress the metal. Okay, so now we have our electrodes that are exposed in our nozzle. So you can see the dirt and debris that develops on these nozzles, and the fuel is sprayed through a tiny little hole right there. That's an orifice that actually has a pattern, which how wide the fuel pattern is or how narrow, and then whether the fuel pattern is hollow like a cone or whether it's solid. In this case, it's going to be a solid fuel pattern. That's what the nozzle tells us. And it is a 60-degree pattern, so it's a fairly narrow pattern. And what we're going to do is remove this nozzle. And again, when we remove the nozzle, fuel is going to come flowing out of here, so we want to make sure we keep it nice and sealed at the bottom here. Okay. So again, this is, on the end of this nozzle is a sintered filter. It's just like compressed little balls of brass. And that's the last line of defense before we clog that teeny little hole with any debris. So we want to make sure we change these every year because these sintered filters do get clogged by really fine particulates and sludge. All right, now that we have our nozzle removed, we want to inspect our electrodes. As you can see, there's definitely a little bit of dust in here. We want to get rid of all that. We want to clean this plate. We want to make sure that these electrodes, these are porcelain. We don't want any cracks in these because the cracks actually can, electricity can travel down these cracks because carbon builds up in those, and that carbon conducts electricity. So we want to make sure there are no cracks whatsoever. We also want to check the very tips to make sure they come to a point. Because again, the electricity goes from one side, arcs across to the other. And if these get blunted, which they do because they get burnt down, that electricity doesn't travel uniformly across. So we may get what we call delayed ignition. There may be too much fuel that sprays in before it finally catches on fire, and that creates soot. We have more fuel than air when that happens. So these ones look pretty good. They're a little dirty, so we're going to clean them. And we take a wire brush. And they're nice and shiny. We want to check inside here to make sure there's no dirt, dust, and debris from cleaning these, and there isn't. Okay, we're going to show you our brand new nozzle that we're going to put in. 85.85, that's how many gallons per hour this nozzle is capable of putting in the system at 100 psi. That's 60 is the pattern, 60 degrees, and the B denotes the shape, or essentially whether it's a hollow or a solid pattern. In this case, B is solid. And here's our new nozzle. That's the nice shiny sintered filters, clean. In the maintenance world, you never want to put your hands on those. You don't want to touch them or touch them as minimally as possible because they're so susceptible to clogging. And we're going to take it and put it in here. And hand tighten it down. And we're going to take our wrenches, and this part's important too. You don't want to over tighten these. There's no need to. You just want to make sure they're nice and snug. They don't need to be over tightened because they'll start to wear this down, this surface that they made against. So just nice and snug is all that's needed for these. And now what we're going to do is we actually gauge these electrodes. The manufacturer, Beckett in this case, has a specific distance that these are far apart and has a specific how far they can be in front of that nozzle right there. So we have a gauging tool for that. All right, so now we're on to the electrodes as far as gauging them and setting them to the manufacturer's specifications. Each manufacturer gives you a gauge, essentially, that they want you to use in order to get the spacing and the distance of the tips of those electrodes the way they want them in their specifications. So you have this type. This is from Carlin, and this is from Carlin as well. That's another burner manufacturer. The burner manufacturer we're working with today is Beckett, and this is the gauge they give us. And how this works is it slides onto the nozzle and locks into place. And there's a little spacer in there. And what they want is that space between these two, and they want them to be just flush with the top. So these ones are actually a little too far out. So what we're going to do is adjust these. You want to make sure that your gauge, this tip, lines up with this notch here. And we're going to loosen the clamp that holds these electrodes in place. You don't need to loosen it too much, just a little bit, so you can move them around, but you can see how they slide. And what I'm trying to do is just scoot them back just a little bit so that they're perfectly level with the top and the space. They're touching that corner, essentially. And then we're going to retighten this. Then we pull this off and we double check. And we can see that they're nice and level with one another. They're the same space apart as this. And they're the proper distance away from the top of the nozzle. And again, it's important because this is all in the name of efficiency so that this thing burns clean. If these are out of the manufacturer's specified spacing, it can take longer to ignite that fuel. And again, if it takes longer to ignite the fuel, you have too much of it in the chamber and not enough air, and we create soot. And that's the one thing we're trying to prevent. All right, now that our electrodes are set perfectly according to manufacturer's specifications, we're going to put the drawer assembly back together again. We're going to put the head on. We're going to reinsert it into the burner. We're going to retighten our drawer tube nut, and then we're going to retighten our jet line nut. We're going to snug our jet line again. We do not want to over tighten this because there's a flare fitting in there. It's actually shaped like a cone and it meets up against a surface. And if you tighten it too much, it starts to mushroom it out and then it won't fit anymore. So we just want to make sure it's nice and snug, which it is. And then again, one final check of everything. And then we're going to go ahead and close our igniter. We want to make sure those springs are making good, clean contact. You can either listen to them touching or visually look in there, which these ones are, with those electrode rods on the end. And then we're going to tighten everything back down again. So that completes the inside and the nozzle changing. A couple other points that we check on this, as we already mentioned, the pressures. We also actually remove this pump off. We inspect the coupling. There's a coupling, which is a shaft that connects this motor that spins everything. And we want to make sure that the coupling has ends on it that are plastic so that if this pump ever seizes, which it can do, it won't cause the motor to seize and burn or catch fire even. So what it does is it breaks and allows the motor to spin freely. We also check the amperage on this motor. It's essentially without that, the system doesn't run. So we check that, because if it's starting to draw high amperage, we're going to want to change it. And this is our primary control. So again, we showed you that little CAD cell eye. This guy controls everything on the burner, and it also shuts the burner down electronically. So we want to inspect this as well to make sure that it is functioning properly. All the terminals are clean. These do have life expectancy. Every component on here has a manufacturer specified lifespan. And again, one of the big things that we stress at Heritage is life expectancies. And what we mean by that is each component, such as this igniter, such as this primary, this motor, the manufacturer, the company that built them, says they are good or useful for this amount of time, 5 to 7 years, 7 to 10 years, whatever it may be. If it is past that life expectancy, we're going to recommend replacing it. Why? Because the manufacturer said it was only good for 10 years. We're at year 11. And at that point, what are we trying to do? We're trying to prevent your system from breaking down. Okay, so next we're going to go on to the brushing and cleaning portion of this boiler. It's a few steps involved with this. We're going to open up the top of the boiler. We're going to remove this smoke pipe. We inspect the smoke pipe. We also inspect the breach or the portion of the chimney it enters. We then will brush and vacuum out the top of the boiler. And then we're going to open up this combustion chamber and we're going to inspect it as well. We're going to inspect it for any damage. We're going to inspect it for wear and tear. And we're also going to get in there and vacuum out the soot that settles to the bottom of that. Okay, there's our smoke pipe. Okay, so now we're ready to brush and vacuum out our boiler. We've actually now removed the top of the boiler and we removed the smoke pipe. And in this particular case, this chimney is lined, and a lot of modern boilers require a liner or recommend a liner to facilitate good draft. A lot of these older chimneys tend to be damaged or worn out, so a nice smooth liner is highly recommended, and that's what's in here in this case. So what we're going to do now is we're going to remove this plate on the top of the boiler to gain us access to where we're going to brush and clean it out. We've also, before putting it back, we have our smoke pipe here. We're going to brush and clean this out, and we're going to inspect it for any damage or defects. Alrighty, as you can see, we've removed the top of the boiler here, and we're going to be utilizing this brush. This is a brush that is actually oval shaped, and it's what we call hog's hair. It's soft, so it doesn't damage the inside of the boiler. And we're going to be utilizing, this is a vacuum down here, but this is the end that we're going to be using. And essentially, this boiler is put together like an Oreo cookie in sections. You have 1 section, 2 section, 3 section. In between the sections are these little tips that you see sticking out. And the whole idea behind those is the flue gases come up through those slits, and those little tips that stick out slow those flue gases down and transfer the heat out of them into the water inside the sections. So what we need to do is take our brush and run it down in between. There's little passes in there. And essentially we're going to be taking our brush and running it down in between them all the way through and back out again. You can see the soot that came with it to clean that. And they go in 2 different directions too. And we want to do that to each section as we go, both directions. So this direction and this direction. Depending on the make of a boiler, this is what we call a single pass boiler, meaning like the flue gases go right from the combustion chamber out the top and then out the pipe. Some boilers pass the flue gases 3 times through them, and those are higher efficient boilers. And they have a different anatomy that we'd be cleaning using a different type brush. But today, this is the type of brush we're using for this boiler. Okay, well, we've got our top of our boiler put back together again, smoke pipes back on. So now this is the final step of the actual cleaning process. We're going to inspect the combustion chamber. We're also going to clean it because that's where all the soot settles, and it's where the flame comes in, and actually most of the soot from the flame will actually end up on the floor in here. So what we're going to do is we're going to open it up, we're going to inspect it, we're going to clean it. Most boilers today are equipped with what we call a swing out door, which this has, where you have hinges on one side. In this case, we can unplug our burner here. And there it is. That's the inside of our boiler. And there's a couple components in here we want to inspect. Number one, there's a liner in here. We have a belly liner or a floor liner, which is a mat, and it's actually made of a ceramic fiber. And then we have another liner here. This is called our target wall. And the target wall, the flame actually, in a perfect world, won't actually hit this. It'll stop just before it. But sometimes the flame does hit this and it rolls up or down, left or right, and that's called impingement. We try to avoid that. So over time, you can see there's some small fissures starting to develop, but those are just surface. The actual chamber's in good shape at this point. So what we want to do is very carefully vacuum and brush out the debris inside here. And we want to inspect just to make sure that there's no leaks inside here. A lot of times you get leaks that'll form at the seams right here, and we don't want that. So again, the boilers, this is a 3-section that's put together like an Oreo cookie, and there's sealant in between these seams, and that erodes with the flame in there. And eventually, over time, if it erodes enough, we'll start to develop a weep or a leak in there. So we want to prevent that. Okay, so we want to take our brush and run it up and down these chamber passes very gently. Now, we're going to vacuum out everything. And behind this, we get soot. So we want to very carefully, and a lot of times you can't do this with a lot of these, is lift this guy right out of here. And you can see underneath it on the belly, see all this soot sits here. And what the soot is actually acidic. This yellow is sulfur. And that's part of the byproduct of combustion. This red is actually the dye that's in the fuel itself. That dye doesn't burn. It forms like this red clay. You can see it right here on my glove. We want to get that out of here. This sulfur sitting here over time, when the boiler's not running, the boiler cools down, we get condensation in there. It mixes with it. This becomes kind of wet, and it starts to eat through the casting. So a lot of times, though, these deteriorate, these belly mats, and when they do, you have to change them. So we do have combustion chamber rebuild kits for these as well. Okay, we finally have our combustion chamber all cleaned out and inspected. It's free of any damage and excessive wear. So the last thing we're going to want to do before we seal this thing back up is we want to take a look at this end of our burner. So this was the retention head that we had cleaned, and we want to check these little holes. Air comes through these holes to help facilitate the combustion. We want to make sure they're not blocked. We want to make sure there's no cracks in here. We want to make sure this ring at the end right here doesn't have any cracks or isn't burnt or melted. You can see if you look in there, there's the tip of your nozzle, and you can see our electrodes. You want to make sure all that's in there nice and tight, which it is, and this is our head again that we cleaned. And everything looks very good. So we're going to close this back up, seal it up, and then do the final step, which is going to be our combustion analysis. Okay, our maintenance is almost complete today. One of the last things we're going to do here is do a combustion analysis. We're going to use this device, which is basically a combustion analyzer. We stick this probe inside the flue stack and we take samples of the flue gases. And there's sensors in here that give us an analysis, basically telling us whether we're burning clean. Because the optimal thing that we want to do today is to produce 0 soot. And we want to make sure that we're burning clean and we have a proper fuel to air mixture. And there's adjustments that we can make to the burner here that can help us facilitate that. But in order for that to happen, we have to know how well we're burning, and that's what this device is going to do. So we're about ready to start the system up, and we're going to turn this on and start to perform the analysis. Okay, we've got the system up and running. Now we're ready to perform our combustion analysis. So I'm going to insert the probe in a hole we've already made in the flue pipe here. And there's a couple different numbers we're looking at. We're looking at our CO2, we're looking at our O2, and we're looking at our excess air. The other important number we want to look at is our parts per million of carbon monoxide. So carbon monoxide is created when we do not have clean combustions. So right now we're only at 5.5 parts per million, which is well under the acceptable range. So we're looking very good in that department. It's actually starting to decrease as the system fires up. All right, the system is settled out now, and we're right around 85.3, which is what I anticipated for this type of boiler. Our O2 is at 12.1, 12 to 12.1, and our CO2, and our O2 is at 4.8. Our CO has gone down to 0.9, which is almost non-existent, and our excess air is right where we want it to be at 30. So this is almost perfect combustion we've achieved with this boiler. So normally we would have to make, again, air adjustments or fuel adjustments in order to achieve these numbers, but today this boiler was right on target. So we're going to print it off. And what we're going to do is we leave this with the customer every time we do a maintenance. And the reason we do this gives us basically a printout of what was on the screen. And this is a maintenance record for next year, so that when I come back to this boiler or another technician comes back, they can compare their analysis from this year to last year to see what's changed, or if anything has changed. So if anything occurs, we know how the boiler was when we left it, as far as how it was functioning. Okay, this is the final part of our combustion analysis. We're utilizing this here, which is actually a smoke pump. And this paper is like a coffee filter. And essentially we're going to pump samples of the flue gases, and it's going to pass through the paper, and then we're going to pump it back into the flue stack. What we're looking to do is filter out any impurities or soot. If we see any soot on this paper, we know we're not burning clean, and we have to make adjustments regardless of what that combustion analysis says. It's just another backup. So what we do is we insert this in the flue stack, and we pump it 10 times. Now we unscrew this, and you can see the ring right there, and it's perfectly white. That means there's zero trace of any impurities or soot in the flue gas. That's exactly what we want. Now, here's an example of what it looks like when there is impurities. This was a combustion analysis done on a different system prior. And you can see the color that shows up there. That tells us that we have soot in our flue gas. And if left unchecked, the boiler will eventually get completely sooted up and then fail to run. So we don't want that. So again, the last thing we're checking is to make sure that we have no soot. So that completes our oil boiler maintenance for today. Today we just touched on a few of the 33 points in our checklist. Again, each and every one of those points is very, very important to the safe operation of your boiler. So if you'd like a Heritage technician to come out to perform a maintenance, please call us. Thank you very much for watching.